Good day, everyone. Let us try to solve this geometry problem. We are given a regular hexagon whose area is 60 units. Inside the hexagon is a green colored triangle. We're going to find the area of the green triangle. To solve this, recall that the areas of polygons are derived from triangles. So we're going to use that approach to find the area of the triangle. Let us start by drawing the diagonals of the hexagon, like that one. Now, if we continue to draw segments in this manner, we will see that the entire hexagon is made up of small triangles, and so as the green triangle as well. This means that if we can identify the area of each triangle, we can simply count how many small triangles comprise the big triangle to find the area of the green triangle. Now, the process of finding the area of these small triangles will be much simpler if we can show that each of them have equal areas. Otherwise, we will resort to a much complicated process. Now, let us choose first to establish whether these triangles are equal and thus have the same area. To do that, let us extend two non-consecutive sides of the hexagon and let these extensions meet at an exterior point, like this one. Now, from this, let us try to establish a relationship to describe the triangle. Since we're not given the measure of the extended sides, we can only resort to the angles. Now, our original figure is a polygon, so let us start there. Now, recall that there is a theorem entitled the polygon interior angle sum theorem, which states that the sum of the interior angles of a polygon with n sides is equals to 180 times n minus 2. Using this relationship, we can have 180 times 4, which gives us 720. That means the sum of the interior angles of this regular hexagon that we are given is 720. Now, since the hexagon is regular, the interior angles will also be equal. So we will have to divide 720 by 6, and this will give us 120. Now, that means each of these interior angles here, this one, will measure 120. Now, this time, let's take a look at this part here, because we are trying to establish the type of triangle that we have using the angles. So let's try to have this one here. As you can see, this angle of the triangle forms a straight line with this one. And a straight line measures 180. Since you already have 120, this is 60 here. And it's the same with this one here. So this is also 60. Now, it is obvious that the remaining angle of this triangle is 60 since the sum of the angles of a triangle is 180. Now, since this triangle have equal angles, what we have now is an equilateral triangle, which is also equilateral. So that means the side of this triangle are equal because the triangle is equilateral as well. Now this time, let's consider this big triangle here. Now recall that these two sides here are equal because they are the sides of a regular hexagon. Since these parts here, these two, are also equal because these are the sides of an equilateral triangle, then we can say that these two sides are equal. Now, let's try to determine what type of triangle is this big triangle. Now, remember that these two sides are equal. That means the angles opposite these sides are also equal. But we don't know the measure of each angle, so let us try to label the measure of these angles as A. That one. Now, Since the sum of the angles of a triangle is 180, we have 60 plus 2a equals 180. Doing some algebra, we will be able to get the measure of a, which is 60. So that means the measure of each angle here is 60. So now the triangle have three angles that measure 60 each. So that means this big triangle is also equiangular, and likewise it's equilateral. That's why this side here will just be equal to the other two sides of the triangle. Now, since the angles are now known to be 60, so these angles are also 60 here. This one here, that one, and likewise this one. Now, remember that this used to be 120 here. So we have this is 60 and this is 60. That's why we have 60, 60, 120. Now, doing this step for the other sides of the hexagon, we can show that the triangles formed by the diagonals are equilateral. Now, this time, let us draw the midline of the equilateral triangles and connect them. We have that one. Now, recall that this is 60 here. And since what we draw here, these blue lines are midlines, then the other two sides are bisected and are therefore equal since they are the sides of an equilateral triangle. Therefore, the angles opposite them are equal. Doing the same algebraic process we did for finding the measure of angle A earlier, we find these angles to be 60 degrees as well. The same process will yield these results here, all of this one. Now finally, let us draw the violet segment, this one here. Doing this, we can now form new triangles, and by using the previous process we had, these triangles are also equilateral. Now we can see that the hexagon is now composed of 24 equilateral triangles. Since they are equilateral, they have the same area. That means the total area of the hexagon, which is 60, is just equal to the area of the 24 equilateral triangles that forms it. So this means that each triangle will have an area of 60 divided by 24, which is equals to 2.5. Now, as you can see, the green triangle is composed of 9 equilateral triangles. So to find the area, remember that each triangle has an area of 2.5 units. Since 9 such triangles comprise the green region, we now have 9 times 2.5, which gives us 22.5, and this is now our answer. Therefore, the area of the green triangle is equals to 22.5 square units. And the problem is solved. So that's it for this video. Please don't forget to like and subscribe to our channel for more geometry problems. Thank you so much. Enjoy learning.